Good morning, students. Chapter 7, System of Particles and Rotational Motion. Yes, we will see some questions today based on lever mechanism. Okay, see, here it is. A metal bar 70 cm long and 4 kg in mass, supported on two knife edges placed 10 cm from each end. A 6 kg weight is suspended at 30 cm from one end. Find reactions at knife edge. See, what is question now? Here it is. You are given a metal bar 70 cm long. For example, here I will draw figure. It is metal bar 70 cm long. Okay, yes, it is metal bar 70 cm long. So its total length it is 70 cm. Its total length is 70 cm. Okay. Let it is end A. Let it is end B. Okay. Now a metal bar 70 cm long and 4 kg in mass is supported on two knife edges placed 10 cm from each end. Two knife edges placed at 10 cm from each end. So yes, this distance is, here it is 10 cm. This distance is also, it is 10 cm. Okay? Okay. 10 cm from each end. A 6 kg weight is suspended at 30 cm from one end. So I am assuming from A and A. A 6 kg weight is suspended at 30 cm. So total length is 70. So 70, its half means its geometrical center will be at this point, 35. So obviously 30 distance 30 will be here. Distance 30 will be here, for example. Okay, so here one weight is suspended, that is named W1. That is named W1. Clear about this? So this distance is, yes, this distance is from this point to this point, it is 30 centimeter. It is 30 centimeter. Any doubt? Okay. Now a 6 kg weight is suspended at 30 cm from one end. Find reactions at knife edges. You have to find the reactions at knife edges. Reactions at knife edges means it is first support. So at this support, reaction is in upward direction, R1 is equal to question mark. And at this point, what is reaction in upward direction? That is R2 is equal to question mark. Clear about it? Okay. Now, first of all, in lever mechanism, you have to identify numbers of forces. See, weight is placed, so it is in downward direction. Two reactions. Also, see, understand first line. A metal bar 70 cm long and 4 kg in mass. This metal bar having mass 4 kg is not having negligible mass. So yes, you also have to consider its mass. You also have to consider its mass and due to its weight. So weight of metal bar W, it is also acting in downward direction. It is also acting in downward direction. And yes, we know that this distance will be, yes, this distance will be, it is 35 centimeter. Any doubt? Okay. So first of all, you have to understand figure in numbers of forces acting. First, I will write each and every force. Okay, in detail. See here. Here, forces acting in system. First of all, W1 is equal to, see, a 6 kg weight. So W1 is equal to 6 into 10, which is 60 Newton due to weight placed at 30 centimeter from end A. Okay, from this end A, this line, see, a 6 kg weight is suspended at 30 kg. Then W is equal to, what is mass of metal bar? It is 4. So it is 4 into 10 is equal to, it is 40 Newton. Hello students, it is nothing but W is equal to mg, okay? It is nothing but W is equal to mg. 40 Newton, it is weight of metal bar acting on center of gravity, and as this bar is of uniform density, of uniform mass distribution, its center of mass and its center of gravity coincide with each other, and that is at its midpoint, exactly at this point. Okay, so yes, W1 is equal to 60 Newton due to weight placed at 30 centimeter from end A. W is equal to this. R1 and R2 are reactions. R1 and R2 are reactions at 2 knife gauges. Clear about this? Okay, so how to write or how to understand data, first of all, that you have to understand. Okay, so yes, total 4 forces, R1, R2, W1 and W2. Now if you know principle of moment, yes, principle of moments, then in principle of moments we have discussed this lever mechanism, it is in equilibrium. And equilibrium means it is in translational equilibrium as well as rotational equilibrium. So yes, we have to apply that concept. Okay, here system is in equilibrium. Your system is in equilibrium. Therefore, first, for translational equilibrium, see, W1 and W, they are weights, so they are always acting in downward direction. Yes, downward direction. So R1 and R2, they are acting in upward direction to balance it. Yes, to balance it. Here again, W1 and W, they are acting in downward direction. Therefore, R1 and R2, they are acting in upward direction. That's why they are acting in upward direction. Okay, so for translational equilibrium, yes, for translational equilibrium, we know that the sigma F is equal to 0. Sigma F is equal to 0 means forces acting in upward direction is equal to forces acting in downward direction. Yes, here it is. So therefore, forces acting in upward direction, R1 plus R2, is equal to forces acting in downward direction, that is W1 plus W. Simple? Yes or no? Okay, so therefore, here it is, R1 plus R2 is equal to, what is value of W1? W1 is equal to, it is 60, while W2 it is 40. So therefore, R1 plus R2, it is 100 Newton. It is equation number 1. Okay, so here system is in equilibrium. So first, for translational equilibrium, sigma F is equal to 0. W1 and W, they are acting in upward direction. Therefore, R1 and R2, they are acting in upward direction. So forces in upward direction is equal to forces in downward direction. Okay, so R1 plus R2 is equal to W1 plus W. Put value, R1 plus R2 is equal to 100 Newton. Now, to find two variables, you need minimum two equations. Okay, yes, first equation, R1 plus R2 is equal to 100. How to obtain second equation? Yes, from second condition. It means if system is in equilibrium, yes, it is in translational equilibrium, as well as system is in rotational equilibrium. It is in rotational equilibrium. And for rotational equilibrium, yes, we know condition. Remember, question or case of center of gravity. Okay, for rotational equilibrium, resultant torque with respect to center of gravity is 0. With respect to center of gravity is 0. with respect to center of gravity. See, when that it is center of gravity O. Okay, so resultant torque with respect to center of gravity is 0. Means with respect to this point O, it is 0. Okay, so now we have to find torque. Torque, what is torque? Yes, torque is equal to, it is force into perpendicular distance. So now, how to find torque? See, there are total 4 forces as shown in figure. Okay, so how to write first of all torque here? Okay, therefore, sigma tau is equal to 0. Okay, but before that, we have to assume, or we have to assign some sign convention. We have to assign some sign convention. Which type of sign convention? See, here I will write in box sign convention. Torque producing clockwise motion, torque producing clockwise motion are considered positive. Okay, torque producing clockwise motion are considered positive, and torque producing anti-clockwise motion are considered negative. How? I will explain. Okay, don't worry about it. So, first of all, this sign convention you have to remember. Okay, torque producing clockwise motion are considered positive, while torque producing anti-clockwise motion they are considered negative. Actually, we have discussed this topic in the principle of moments. Okay, so now we will revise this topic. Don't worry about it. Yes, sigma tau is equal to 0 with respect to point O. With respect to point O. Okay, yes, here it is O. So see, W, weight of metal bar, it is passing from point O itself. So due to that, torque is 0. So I can directly write W into 0. Simple. No plus or minus sign required. Okay, no plus or minus sign required. Now, next one, W1. Okay, W1 and this W. What is distance between them? See, distance between them is this. And this distance is, see here carefully, it is 35, it is 30. So distance between them, it is 5 centimeter. Simple. It is 5 centimeter. So yes, here I have to write it is W1 in bracket 5 centimeter means 0.05 meter. But plus or minus sign. How? See, about this point you have to find torque, and force is acting in this direction. W1 it is in this direction. Then how to find? See, here it is. Here it is. It is point O. It is point O. Okay, W1 is acting in this direction, in downward direction. So it will perform like this motion. Again, see here. It is point O. W1 is acting in downward direction. So which type of motion is performing? See, which type of motion it is performing? Anti-clockwise. Yes, anti-clockwise. Okay, here I will draw arrow. So you can easily understand. It will perform motion in this direction. Okay, anti-clockwise. So that's why I have to take its negative sign. I have to take its negative sign. Okay, now next one. W1 over, now R1. So for R1, just here it is R1. What is distance from this point O to this R1? See, this distance is 35. This distance is 10. So obviously distance between O and this first knife it is 25 centimeter. Means it is 0.25. Means it is 0.25. Now plus or minus. Again, it is point. Forces acting in upward direction. So about this point it will rotate in clockwise direction. Like this. It is point O. It is point O. Forces acting in upward direction. It will perform clockwise motion. It will perform clockwise motion in this direction. In this direction. So it is considered positive. It is considered positive. Okay. Now next one, that is R2. R2. What is distance of R2? Again, from this point O, this whole distance is 35 centimeter. It is 10 centimeter. So it is 0.25. Now it is plus or minus. It is plus or minus. That again we have to find. It is a plus or minus. Then how to identify this plus or minus? See, here it is. Again, it is point O. This one is fixed. R2 it is in upward direction, means in this direction. Means in anti-clockwise direction. Means in anti-clockwise direction. And as it is in anti-clockwise direction, you have to take a sign negative. You have to take a sign negative. Okay? So now how to write this equation? Now how to write this equation? See, here it is. Here it is. Minus 0.05 W1 plus 0.25 R1 minus 0.25 R2 is equal to 0. Yes, is equal to, it is 0. Okay, so therefore, here it is. How to write this one? See, 0.05 means 5 divided by 100. 25 divided by 100, and that is also 25 divided by 100. Yes or no? So 100, 100, 100 we can cancel out. Okay, so it is 5W1 plus 25 R1 minus 25 R2. I can write this W1 on opposite side. Okay, A is equal to, it is 0. So therefore 25 R1 minus 25 R2 is equal to 5W1. Is equal to 5W1. So therefore 25 common, here it is R1 minus R2. 5. What is value of W1? W1 it is 60. It is 60. So therefore R1 minus R2 is equal to 5 into 6 is 30. It is 300 divided by it is 25. Divided by it is 25. Any doubt? Okay. Okay now. So yes, R1 minus R2 is equal to, it is 300 divided by 25. Is 300 divided by 25. Now how to solve this? So yes, without calculator, how to solve this? 300 means it is 30 into 10 divided by, it is 5 into 5. 5 into 2. 5 into 6. So 6 into 2 it is, I think, 12. So therefore R1 minus R2 is equal to 12 Newton. This equation number. So yes, you have two equations. R1 plus R2 is equal to 100 Newton and R1 minus R2 is equal to 12 Newton. Yes, is equal to, it is 12 Newton. So yes, now you can easily find R1 and R2. See, physics over. Okay. Now it is topic of maths. If you are given two equations, R1 plus R2 is equal to 100 Newton and R1 minus R2 is equal to 12 Newton, then how to find values of R1 and R2? Yes, you have to add two equations. So R2 and R2 will be cancelled out. Then find R1 and then from it find R2. Okay, it is topic of maths. So yes, it is one important question from chapter number 7, which is based on equilibrium of the whole system of this lever mechanism. Clear about it? Okay, yes, it is long question. So for today, this is it.